right, so section 1.4, we're going to continue our discussion of linear equations. We talked briefly at the very end of the last section about linear equations. We talked specifically about x-intercepts, y-intercepts, and then horizontal and vertical lines. So we're going to continue that idea, and we're going to talk about the lines that aren't horizontal and aren't vertical, and so they have some other kind of slope. So the slope of the line through the points x1, y1, and x2, y2 is found by taking, well, m is the reference, is what we call slope. M is slope. So it's y2 minus y1 over x2 minus x1. If you want, you can write it as y1 minus y2 over x1 minus x2. That's fine as well. Doesn't hurt anything. So you could switch the ordering of the numbered points there. Or another way that sometimes people think about it in terms of a picture point of view, maybe a little bit more, is they think of it as rise over run. How far up and down the rise over how far left and right the run. So we're going to take 3 different sets of points, and we're going to find the slope when we calculate it given 2 points on a line. All right? So these are 2 points on a line, 2, -1, and 5, -3, and we're supposed to find the slope. So again, it doesn't matter which ones you label what, so I just usually label them from left to right, x1, y1, and then x2, y2. Okay, the only thing that matters is the subscripts match. So I can't go x1, y2. That's not okay. All right, I can't also go x1, x2. That doesn't make any sense. It's got to be an xy ordered pair. All right, so I'm supposed to take the second y value, which is -3, minus the first y value, which is -1. So now I have -3 minus -1. And we'll do the same thing with the x's. The second x value, which is 5, minus the first x value, which is 2. So I have 5 minus 2. Okay, so what's minus a negative? So I actually have -3 plus 1 on top now. So what is -3 plus 1? Good. On bottom, I have 5 minus 2. +3. 2 and 3 don't have anything in common. So we stop. My slope is -2/3. And what that's actually telling you is that, in terms of the rise over run, is that I go down 2 and right 3. That's what the slope would look like on a graph. Down 2, right 3. Let's do 2 more. I have x1, y1, x2, y2 slope. So I have the second y value is a 3, minus the first y value is a 3, over the second x value, which is -10, minus the first x value, which is 7. So what happens on this one? It is 0 on the top. I have -17 on the bottom, although it's kind of irrelevant. I end up getting 0 for the whole thing, of course, right? The slope here is 0. What did it mean when we had a 0 slope? It's horizontal. This is a horizontal line. So if we were to create the equation for this line, it would simply be y = 3. But that kind of makes sense. Look at the points. The y value in both of those ordered pairs is 3. Right?
What if you had this same scenario, but the y, well, I guess that wouldn't make any sense.
Yeah, so we need it.
What if they were different? That wouldn't make any sense.
Yeah. Okay, let's try another one. 3. Slope. Again, x1, y1, x2, y2. You don't have to label these. I'm just doing it as a reference point so that when we're working together, we're all on the same page. So the second y value is -3. The first y value is 9, so -3 minus 9. The second x value is 4, minus the first x value is 4. So what does my numerator become on this one? -12. And what happens on bottom? 0. That is undefined. Okay? Anytime you try to divide by 0, that is an undefined operation, which makes this an undefined slope. So think back again to Hooyvaks, right? The vux, the undefined, is vertical lines. Damaris.
Well, since both of them, the their x's are 4, does that mean you draw a line on 4?
Yeah, if you were trying to draw it, your x equals 4 would be the equation of your
But
line.
it'd still be undefined.
Yep, still be an undefined slope. It would be a vertical line. We still have a line, it just doesn't have a slope. The slope's undefined.
Why is this one undefined and that one's not?
Because it's okay to do 0 divided by something, it's not okay to divide by 0. Right? If I have 0 cupcakes, which I have 0 cupcakes right now, and I divide it among everyone in the class, and there's 20 of us, we all get 0 cupcakes. So we can divide 0, okay, but we can't divide by 0. That's an undefined operation, okay? All right, any questions about finding slope? Okay. There are actually at least 3, we're going to talk about 3 forms of linear equation, okay? The first one I mentioned back in section 1.3, and its equation, it was ax plus by equals c. Absolutely the least helpful form of a line, but it is the standard form of a line. There's some conditions on a and b you should probably know. A and b need to be integers, so they shouldn't be fractions or decimals. And the a value is supposed to be positive, right? But the issue really that kind of makes it unhelpful for the most part is that the x and the y are on the same side. It's not a very helpful form of the equation.
What the heck?
All right. The next one is called point slope form. So point slope form looks like this. Y minus y1 equals m times x minus x1. So shake your head if you've seen that before. Yep. It's actually a really helpful form of a line. It's not necessarily one that we always want to leave the equation in when we're done answering it, but it's pretty helpful. If I have a slope given and I have a point given, that happens a lot of time, this is a great way to actually create an equation. Now, a couple of things that I want you to notice in this equation, because it looks like there's lots of variables, and there really aren't. Y1 is a number, m is a number, and x1 is a number. And you always have numerical values given or that you've found for those quantities. The only variables are x and y, just like they were in the first one with ax plus by plus c equals c. Okay? The last form of a line is the most familiar, typically. It's the one that's most friendly in terms of your calculator to being able to graph something for you. It is y equals mx plus b. It's friendly because you can see the slope, but you can see the slope on the other one, right? And it's friendly because you can see the y-intercept at the end. It's the b value.
So which one would you say is if we're trying to like, we're only given the numbers and not like the actual coordinates, if we're trying to find the coordinates, would you say point slope form is probably the best one to use?
Can I hold off on answering until we've done some examples, and then I think you'll have an idea. Will that work? Awesome. Thanks so much. Yeah, we're definitely going to look at that. I'm going to show you a couple different options even on how to think about them, because there's not just one right way. There's usually more than one. So, all right, let's do some examples where we have some equations, or some points given anyway. All right, on number 4, it wants us to find the equation of a line. It doesn't tell us what the equation has to look like, right? I mean, it doesn't. Sometimes my math lab might tell you at the end, state the final equation in point slope form, or state the final equation in slope intercept form, or state the final equation in standard form. It might tell you a form at the end. Okay, so we'll talk about that a little bit here. But right now, this one just wants us to find an equation. So we have 2 ordered pairs given. And regardless of which of the two, the second and the third form you like, they both revolve around us knowing the slope. And right now, I don't know the slope, but I do know how to find it, right? Yeah, we did it already, right? So our slope is found by taking the second y value, which was -3, minus the first y value, which is -1, divided by the second x value, which was 5, minus the first x value, which was 2. We added the ones up on top because it's minus a negative. And lo and behold, we've got -2/3. This is the problem we did earlier, right? We already did this one.
How did you know like which equation to use on that?
Well, if you take a look at number 2 and number 3 here, the different forms, they all or they both, I should say, they both have m in them. M's the slope. I got to have a slope before I can continue.
Okay.
That's why. I need a slope. So I calculated the slope first.
Okay.
Okay, so I have the slope and I have a point. So I'm going to show you two ways to go from here. One of them is to use the point slope form of a line. So if I'm using point slope form of a line, that's y minus y1. I'm just going to write it down first to remind you. Times m times x minus x1. That's the point slope form of a line. Now, I actually have given two ordered pairs, right? Pick your favorite. Doesn't matter. You're going to get the same equation no matter which one you pick. I'm going to pick the first one just because the numbers are smaller. It's not even a really good reason. I just am. That's the one I'm choosing. Okay? So the first the y value in the first pair is -1. So this is y minus -1. I'm going to leave a space for a moment. And then the x value in the first pair is 2. So it's x minus 2. Okay, so I filled in y1 and x1 from the original blue shaded point that I've got there. M is what I found. It's -2/3. So it goes right there. Now, the reality is that that's an equation with the given conditions, and if I weren't asked to do anything different, I might be able to actually stop there. But there's a really good chance it's wanting you at the very end to write it as y equals. That happens a lot. So I want to make sure that you're able to do that too. So let's actually solve this for y and see what we end up getting. So I'm going to first need to distribute the -2/3 through. So, oh, and I might also notice that this is y plus 1 now on the left because it's minus a negative. So I have y plus 1 on the left. On the right, I have -2/3 x. And then I have -2/3 times -2. +4/3. Perfect. Okay. And then I need to subtract my 1. Let me make this a little bit smaller since my screen's overflowing the board. So, of course, this eliminates on the left-hand side, leaving me with y. I still have the -2/3 x. But in order to combine these, I need common denominators, right? Okay. So 4/3 minus 1 is the same thing as -3/3, because 3/3 is the same as 1. What will I get? 1/3. It's positive. You would leave it like that if you were asked to find it in the y equals form, which is a pretty standard way that you're asked to give your equation at the end. That's pretty common. Okay, I want to show you one other way, but first, Damaris, do you have a question on this one? Yep, there is another way. So let me cut this off for just a moment. The other way still involves us finding the slope. So this part would be the same, okay? So we still have to find the slope. But you could actually use the equation y equal mx plus b directly instead of finding it at the very end. So let me show you what I mean by that. Well, again, you have two ordered pairs, right? Pick your favorite. So the x or the y value is -1. I'm going to put y as -1 in. The slope that I found was -2/3, sorry. And then the x value in that first ordered pair is 2. So what I can do, if I choose to do it this way, is I can actually solve for b. I already solved for m. I can solve for b, and then I can stick them all together in the equation at the same time. So if I do this way, I've got the -1 equals, so -2/3 times 2 is -4/3 plus b. Then I would add my 4/3 to the right and to the left. I still need a common denominator. You might be feeling like, well, didn't we just do all this? Yeah, you're just doing it in a different patterning and different order, right? Like all the steps have to still be there pretty much. So I do need to change this into 3/3 in order for this to work. So I have -3/3 and +4/3, which makes 1/3. And then I can write my equation. It's y equals, m was -2/3 times x, b is 1/3. Yes, ma'am.
Is it gonna ask for us to do it a specific way?
No.
Okay.
No. It might ask for the answer to be presented in a specific way, but it wouldn't ask for you to do it in a specific way. Good question.
What does the x after m represent?
Well, remember, this is an equation of a line. So x is the ordered pair in every point on the line, and y is the y part of the ordered pair in every point on the line. So it's representing a location, how far left and right you are from the y-axis, really. Okay. Ready to try another one? The next two are faster. They're fast, like super fast. You ready? Okay, so this question, these two ordered pairs, they mirrored the ordered pairs you had on problem number
It's not on the board.
1. Yes, it is. This is exactly my screen. I'm not switching to the next one yet.
Oh.
This question that we just did, number 4, was the same point, the same that we had over here. So 1 and 4 were the same pair of points, right? So I'd like you to notice that on number 2 we have 7, 3 and negative 10, 3, and on number 5 we have 7, 3 and negative 10, 3. Okay, I paired them up on purpose because I don't want us to rework the things over and over again. I'm just sort of drawing your attention to the fact. So we did this. This is from problem number 2. And when we did this, we found out that the slope m is equal to 0. Remember that? We also talked about that this meant that this was a horizontal line. We mentioned it anyway, right? So if you know those details, you should be able to answer the question, what's its equation, very quickly. And Hooyvuk's is one way to do that. If it's a horizontal line and it has 0 slope, then its equation is y equals. And what does y equal? Well, 3. Y equals 3. If you don't remember those details, you can still get there. You're just going to do more work. You're going to end up doing y minus, and you pick a y value 3, equals m, which is 0, times x minus, and then you can pick an x value, 7, and you'd solve this. And as you do, of course, you'd end up getting y equals 3 anyway. Hooyvuk's works really nicely if you remember the details, or at least remember the concept behind them, so you don't have to create an equation with all the details in there because they aren't really all there. At least not all in numerical form. Number 6 is, again, mirroring back to problem number 3, where we found that we had an undefined slope. Say again, Kaylee? It is a vertical line, you're right. Which means that this is an equation x equals. And what does x equal? 4. Damaris? Okay. If you think of it, let me know. So it's really valuable to be aware when you have those undefined or those 0 slopes, and not just to always go back to a specific equation, because you don't need an equation to plug things into on these two. They're either x equals or y equals. Okay, Damaris, you remember it?
Yeah.
What's up?
Is a vertical line always going to be an undefined slope?
Yes, always. Kenny?
Is it easy to tell that it's just going to be x equals 4 because both of the x's are 4?
Yes, you can also think of it from there. Absolutely.
Okay, which is why it's a horizontal.
It's exactly why. The other thing that's true, and this is another thing too, I'm always about having lots of ways to think about stuff. The other thing is true is that if you were to plot those points, I think you'd figure out pretty quickly whether you have vertical or horizontal lines.
Oh, gee.
Are you with me? Yeah, if you plotted those points on an XY coordinate plane, you'd see, oh, well, in order to connect them, it's vertical, or oh, in order to connect them, it's horizontal. You still need to remember that it's x equals or y equals, but you could see it pretty quickly in terms of the visual.
Wow.
Okay,
Magic.
now we're going to compare lines. You ready to compare lines? I am. C. Oh, I had one more. Sorry, so you weren't ready. I'm so sorry. All right, here's another one. This one's actually kind of given to you a little bit differently. Instead of giving it to you with 2 ordered pairs, they're actually giving it to you with a slope. That's very friendly. Because if they're giving it to you with a slope, then you don't have to calculate the slope, right? So let's actually do it both ways again one more time, just so that you have a reference point for both of them once more. So we have y minus y1 equals m times x minus x1. So my y1 value is 9. The slope was negative 1/3, and the x1 value is 6. This is one way. So we will distribute our 1/3 through. So on the left, I still have y minus 9. On the right, I have negative 1/3 x. And what is negative 1/3 times negative 6?
6/3.
Uh-huh. Positive and 2. Yep.
Because you simplify the.
Simplifying the 6/3. And then we would add the 9. So y is equal to negative 1/3 x plus 11. Okay, so that's dealing with it from the point slope form. If you want to deal with it from the slope intercept form, that is the y equal mx plus b, again, it's going to be the same numerical values showing up again. Y was 9. The slope is negative 1/3. X is 6. B is the only thing I don't know, and I can solve for it. So, what is negative 1/3 times 6? Negative 2. Make sure you get that one negative this time. That one's negative. But then if I add the 2, of course, I end up getting the same number 11 I had before. B is 11. Okay, so the most common error that students make when they do this problem, at least when they're doing it in written form, maybe not on the computer because it kind of guides you along a little bit better with how it asks you to write things in, is to stop. Just to stop. You found out what B is and think you're done, but you didn't find the equation of the line yet. You have to actually put it all together. So y equals negative 1/3 x plus the 11 would be putting it all together at the end. Okay. All right, next one, parallel perpendicular lines.
Yes.
So, two lines are parallel if they have the same slope. So, parallel lines, often we kind of think about them or talk about them like railroad tracks, right? They go side to side all the way. However, the definition of parallel lines is not that they never cross, although that's true. The definition is that they have the same slope. The rise and the run is the same. The rise over the run is the same. Two slopes or two lines are perpendicular, right? Perpendicular means they cross at a 90-degree angle if their slopes are negative reciprocals. Okay, so y'all know what reciprocals are because we've talked about them. Reciprocals are the flips of fractions, and if it's not a fraction, we put it over 1 and then we flip it, right? That's what our fractions would look like. We flip them. That's my reciprocal. The fact that it says negative reciprocals simply means that one's positive and one's negative. So if we're comparing two equations, slopes, and we think that they are perpendicular, one has to have a positive slope, the other has to have a negative slope. And if you think about it visually, that should make sense, right? One slope's going downhill and the other slope is going uphill. Okay? In order for them to both be going uphill, they would both have to be looking something like that, definitely not crossing at a 90-degree angle. Are you good? Okay, no problem.
If the slopes are negative,
Mm-hmm. So the idea is that we're going to be given, generally, an equation of a line, and we're going to be asked to use that line to create another line, a line that's either parallel to the one we're given or one that's perpendicular to the one we're given. Okay? But it all hinges on knowing the slope of the line I'm given, right? These definitions are all about slope. So I have to be able to take a line and figure out what the slope is from the lines equation, not just from an ordered pairs equation like I have been doing. So here is a line. It's in standard form. At least it's given to us in standard form. 3x minus 6y equals 7. Okay? I need to find its slope. Well, the nicest version that identifies the slope very easily is the slope-intercept form of a line. In other words, if I get it to say y equals on the left and I've moved everything else on the right, I should be able to figure out, simplifying and so forth, what the slope is between what's lying on the right-hand side of the equation. So as we're taking a look at this, we're going to take this equation, and sort of, if you will, step one is to solve for y. If you want to just write yourself a note down, that's how I'm going to do it. I'm going to solve for y. So I first need to move the x part. So I will subtract 3x. So that leaves me with negative 6y on the left. I'm going to put the x term at the beginning simply because if I'm comparing it to y equal mx plus b, the x is at the beginning and the 7 at the end. Okay, I'm just trying to mimic it so that it ends up looking like y equals mx plus b when I'm done, because I can clearly see then that it's the number multiplied by m, or by x, that's my m. But I need it solved for y first, so what's my next step? Yeah, divide by negative 6. And again, it's easiest for what we're doing to divide each individual term, each piece by the negative 6. So on the left, these cancel, leaving me with y. On the right, the signs cancel, right? They're both negative. How else will the 3 and the 6 reduce? Yeah, they'd reduce to a 1/2. They both divide by 3. So this is a 1 and a 2. So I actually end up with 1/2 times my x. And then the reality is that while it's true that it's negative 7/6 at the end, it's sort of irrelevant. I don't really care what the y-intercept is for finding this information. All I really needed to find was the slope. And I have it now, right? The slope here is 1/3. So, 1/2, sorry. 1/2, sorry. So, if I wanted to find a parallel line, which is what this one asks me for, then its slope is also going to be 1/2. If I were told to find a perpendicular line, what would its slope be? Negative 2/1. It's the reciprocal and change the sign. This one's positive, that one would be negative. Now, this one does say parallel. So my slope will in fact be the negative, or the 1/2. And my ordered pair is this one right here. So now that you have a slope and you have an ordered pair, it's the same thing we just did on this problem. Slope, ordered pair. So we get to pick an equation, so I'm going to let you guys tell me which one you want to use. Do you want to use, we're going to go the one on the left or the one on the right? Left? All right, point slope. Most of you are saying the left one, so we'll go with that one. If you like the other one, do the other one instead, and you'll end up with the same answer. It'll be okay. All right, so y minus y1, well, y1 is 2, equals the slope we just said was 1/2 times x minus the x value, which is negative 4. So far, so good? Excellent. Again, most of the time your My Math Lab and so forth is going to want this in y equals form, so we're just going to sort of make that our standard operating procedure that we keep solving until we get y equals. Minus a negative is plus. So now have y minus 2 equals 1/2 times x plus 4. What would I do next? Distribute the 1/2 through. So again, y minus 2 equals 1/2 x, and then I need 1/2 times 4. It would be 2. And then what's my last step? Add the 2. So y equals 1/2 x plus 4. And I realize as I'm looking back on my next problem, I missed something. But this is what the y equals form would look like. I want to pause for a second because I inadvertently did not pay attention closely to the directions. And it actually told me which form it wanted. And it wasn't y equals. I'm so sorry. This is what happens when you don't pay attention. It's great practice, though. We have a couple minutes extra. We got no problem with it, all right? We're going to turn it into standard form now instead. Okay, you ready?
Wait, how to go from this to standard thing?
I don't care which one we go from. We can either use this one to go from standard form, but what we're actually going to do is we're going to just go from when we did it here. Everything to there would have been the same, okay? All right, so we're just going to go back a couple steps, and I'm going to turn it into standard form instead. Are you ready? Okay. Okay, if I had stopped right here, all this would have been the same to get to standard form anyway, okay? So using this to get to standard form, you'll notice that in standard form, it looked like this. With all of the x's and the y's on the left and all of the numbers on the right. That's standard form, okay?
AX plus Y.
AX plus BY equals 0.
See?
It's off the top of my screen. I'm so sorry. This is a terrible projector for when I have to go on hardwired in. It really is. How about that? Is that any better? It is supposed to be equals C. I don't even know why I wrote equals 0. So sorry.
Because it's fun.
That's not it. All right, AX plus BY equals C. That's what it's supposed to say. My apologies. Okay, let's continue back to where we were. So you can actually add the 2 to the other side, just like we did as that last step before anyway, because it's where it needs to be. So this is Y equals, it is 1/2 X and plus 4. But I need to move the part that's got the X in it, this piece, over to there. So it needs to be subtracted, okay? I realize I'm out of screen space, so let me shrink what I've got. All right, so we're going to subtract we're going to subtract 1/2 X like this. Now you'll notice that the X value is in front. So this is negative 1/2 X plus Y equals 4.
Wait, so do you have to do that whole beginning process?
Why didn't it shrink enough?
Just to do the AX plus BY?
Yeah, you do. Yeah, you do. Eventually you're going to have to move things around. I didn't have to move the 2 first. I did. I could have moved the 1/2 first, 1/2 X first. That'd be fine.
So that's it?
No, it's not.
You have to subtract the Y, or, I don't know.
Because that's a Y.
Okay, yeah. Okay, so I need more space. I'm just going to delete what's here for now. I hate deleting my screen, but I don't have any more space. So here's where we are at this point. Okay, that's where we are, right? Okay. There are some conditions on A and on B. First of all, they got to be positive. Like the A value has to be positive. Not B, but the A value has to be positive. So how am I going to take it from negative and make it positive? Either divide everything by a negative, multiply everything by a negative, or simply change all the signs. It's going to be the same thing. Multiply or divide by a negative. So I'm going to write multiply. You can write divide. Totally doesn't matter. We're going to get multiplication or division by a negative. Come on. There we go. All my signs are going to flip. So this is now going to be 1/2 X minus Y equals negative 4. All my signs flipped because I need a positive sign at the beginning of the A term. The second thing is that the A value and the B value can be fractions or decimals. They have to be whole numbers, or at least integers, I should say. So we're going to multiply by 2. So Bailey, how'd you get a 2? You're right. How'd you get a 2? Right. I need the reciprocal of 1/2. Or not necessarily the reciprocal, but at least the denominator part, right? Yeah, I need to multiply by that denominator. And if the middle term, the B value term, were also a fraction, we have to multiply by both their denominators, right? Or a least common denominator, which we've done before. Shake your head. You've done it before. I know you have. Multiple times. Okay? So we need to get rid of the denominators. No denominators. So on this one, this would give me X minus 2Y equals negative 8. And that would be standard form.
So, multiply by 2 because you can't have any, like, fractions on
Right.
A?
On A and B, it's just that B didn't have a fraction here, so we didn't have to worry about it.
And it doesn't matter about C, it's a fraction or not?
Yeah, no fractions in C either. But again, we didn't have one in C. So yeah, no fractions in any of the coefficients. All the coefficients need to be integers, either positive or negative whole numbers. Yep. It's a mess. I'm so sorry. All right, we're going to do another one, though. Y'all ready? I knew you were. I knew you were ready. It's perpendicular. You're gonna like number 10, but we're not on 10 yet, we're on number 9.
Let's not like numbers.
You're gonna love 10, I promise. All right, number 9, perpendicular, right? Perpendicular. So again, in order to find something being parallel or perpendicular, I need to know what slopes I'm talking about to begin with. Agreed?
Yes.
Yeah. I need to figure out what the slope is of this guy. So I have x minus 2y equals 3. So to find the slope, I need to get y by itself. So I will subtract my x. So it's negative 2y. I'll list the x first because it will most closely look like y equal mx plus b. And then I'm going to divide each term by negative 2. Okay.
Wait, hold on, what did you do?
Well, first, I subtracted the x to the other side. And then secondly, I'm going to divide everything by 2. So I've written everything with a denominator 2. Okay, everybody good so far? Excellent. On the left, of course, this is y because the negative 2's cancel. On the right, the negatives cancel. So I'm left with x over 2. What's my slope? 1/2. So x over 2 is the same thing as 1/2 x. Or if it helps you, you can write 1x over 2. But there's 1 understood to be in front of the x. Is everybody good with that?
Yeah.
Okay, so it is a 1/2 slope. The last piece, again, rather irrelevant for the moment, is negative 3/2.
So is it 1/2 x? Like we need the x there.
Well, you need the x there in the equation, but the x itself is not part of the slope. The slope is 1/2. So when I identify my slope here in a moment, it's just a number, 1/2. And I have an ordered pair over here, negative 3, 1. So we're going to do y minus, my y value is 1, equals my slope, which is 1/2, times x minus the x value, which is negative 3. So minus a negative is positive, so this is x plus 3. Oh, I'm sorry, I made one mistake before I continue. My slope of the original one was 1/2, that's true. My slope then of my perpendicular is what? Sorry, I got a little carried away. Yeah, it's negative 2 or negative 2 over 1. Purging perpendicular lines. Perpendicular lines. That's great. There's no fractions, right? Yay! This little symbol, do you see that upside down T?
Yeah. Okay.
This symbol, in case you haven't seen it in a while, is a perpendicular symbol. That's what I used. If you want to write the word perp, like in an appropriate way, as in perpendicular. Perp, right, P-E-R-P. It's a perpendicular. Yeah, that's what that symbol means. Okay, so I need a negative 2. Right here. Cool. All right, so I have y minus 1 equals, and we'll distribute the negative 2 through. So, wow, negative 2x, negative 6. Multiplication, not addition, multiplication. Yeah, negative 2 times 3, negative 6. All right, so I need the x's and y's on the left, and I need the numbers on the right. Right? You want to add the 1 first? Okay, we'll add 1. So now I have y equals negative 2x minus 5. Then what? Yep, we're going to add 2x. So now I have 2x plus y equals negative 5. Standard form. Yeah, same directions as the previous slide. Standard form.
Is that it?
That's it.
How come we got to that the first time and not the second time?
We had more to mess with the first one we did because we had a fraction involved.
You said we would have.
Right? I didn't say you did.
The point slope form? Like
We used the point slope form. We actually got the slope intercept form in between there. Do you see it? We did the slope-intercept form on the inside. It's just that we were able to get from slope-intercept back into standard form more quickly because number one, there's no fractions. And number two, x was already positive when we shifted it over.
Okay, so
Those are
it did-
both
it
things.
did the same thing, it just went quicker.
It went a lot quicker because the numbers were nicer. Exactly. Damaris.
Is it okay if we do it where we, like I've been using the y equals mx plus b form,
Mhm.
and I just don't put anything in for b, and then I just substitute in that point, and then I get the right answer.
Yes.
Okay.
I did that on an earlier problem. You can definitely do it that way. Absolutely. Okay, you ready for the last one? I wasn't saying that you wouldn't like number 9. I just know for sure you're going to really like number 10. You are, I promise. Oh, so I'm curious, Jasmine, when I'm right, what do I get? Okay, you're going to just wait and see? All right. X equals 7. What in the world is x equals 7? It is a vertical line. Correct, but you're right, it's exactly what it is. But if I have a vertical line, and I want something perpendicular to it, what will it look like? A horizontal line. So this one's vertical, so the perpendicular will be horizontal. How do I get the equation of a horizontal line?
Y equals?
It's y equals. And what will y equal? 2. How did you know, Bailey?
Damaris said, no, I'm just kidding.
Because Damaris said it.
No, I'm just kidding, that's not why I said that.
Because it's in the ordered pair, right? It's the y value in the ordered pair. Okay, that's it.
Okay, I'll do like this.
See, I told you would. I promised. All right, but if you think about it, here's what's happening. I'm going to just draw real quick from the graphical perspective. You have x equals 7. So x equals 7 is something like over here. I don't know, roughly speaking, okay? It's over there. That's x equals 7. And we have this ordered pair at 1, 2. So, it's about like right here. I know I'm not drawing things to scale, but you get the right idea. So as I'm looking for my perpendicular line, it would have to do this at the same height that the point's already at, which is a height of 2. So that's what's going on from a visual perspective. But that's because there's a really nice relationship between horizontal and vertical lines, and Hoivex can help us to remember those details as well.
Who?
Who?
Oh, you stepped out there.
Hope.
Is it supposed to graph on my math lab? On all these problems?
Sometimes it asks you to graph on my math lab, sometimes it doesn't. If you find as you're doing it that your graphing part's not working, you may need to check in with IT to figure out if there's something that needs to be installed or changed, like settings-wise on your computer to make that happen. So I know that on my Mac, I had issues with graphing at one point, and sometimes that happens. So if you have a Mac, I think you're probably more likely to run into that problem than if you have a PC.
Mine's still working fine.
Yours is working fine?
Yeah,
Awesome.
we had to graph a couple problems.
Fabulous.
Like the circles.
Okay, so we've been like pushing the envelope on being done on time, and now we actually are done on time. So we're going to have 2 homework assignments you need to have finished inside of my math lab tomorrow. Homework 1-3 and homework 1-4. If you've been doing what I've asked you to do, part of your 1-3 should be already done. Okay? You are also doing what for me tomorrow? A homework quiz. A homework quiz. So, especially for those of you maybe who weren't here yesterday or didn't remember the details, I have all of the PDFs for all the homework sections in Chapter 1 in Canvas. So if you're having a hard time finding them in my math lab, you should be able to access them simply in Canvas and pull them up from there. It is in your best interest to do all of those homework problems. There are 16 of them. It is just sections 1 through 3. I know we've finished through 4, but it's not on the quiz because the quiz was already made.
So we need to do 1.1, 1.2, 1.3.
The written work for 1-1, 1-2, and 1-3. That's what you should bring with you tomorrow, those 3 sections. Okay? All right. I will see you guys tomorrow.